Greetings. Welcome to lecture number 4 of vector. In the previous lesson, we have learned about divergence, the gradient, vector product, dot product, cross product both, and some of the vector properties. In that lesson, we will learn about curl. Before we start, we are mentioning that the high quality study materials have attached in our description box. And one more thing, this chapter will read in some of the part. First, we will learn the physical meaning of the curl, then how mathematically represent it, and we have to find that whether the mathematical representation and physical representation contradict each other, and finally we will have some example. Let's start. Look at the image. This image is a image of whirlpool. Here we see a rotational force of water, and there will in the middle we see an force on the perpendicular direction from the water body. Okay, uh, to understand it, this is a physical example of curl. To understand that phenomena, let's understand the curl more deeply and with another physical example. Suppose and body we keep here, suppose we keep a body there, and two kind of force apply in this. One is from that side and another force is from that side. Then what happened? Then this body will start rotating. In which direction? From this side, for this side and this, the body will start that rotating. This concept of applying the force from another direction, the rotation starts, is the concept of curl. Let's start to learn it mathematically. The mathematical concept of curl is basically this is the cross product of nabla operator with any vector. Okay, suppose we have to find the curl of vector A, that can be written as that cross A, that is the curl of vector A. Okay, now take the vector A is equal to ax I cap plus ay j cap plus az k cap. That is the vector we have taken, and we have to find the curl. Before we start the finding it, let's understand that a very basic rule what we have already learned in our cross product section. Okay, that in a cross product I cross j is equal to k cap. This is very important to remember to solve this thing. J cross k is equal to I cap, and k cross I will be j cap. One more thing, for if it is j cross if it is instead of j cross I cross j, it will become j cross I, then it will be minus k, and same for the all. Okay, now uh, let's break this expression. This is the nabla operator cross of product. First write in the nabla operator form. What is the nabla operator form? In our gradient part, we have learned that nabla operator form of nabla operator, that is look like del y j cap plus del of del z k cap, that into this term x I cap. Okay, it is cross product plus ay j cap plus az k cap. Okay, now let's start to remember one thing, that for a cross product I cross I will be always 0. So we are not wasting our time by writing that I cross I term or j cross j term or k cross k term. We just start from that I cross j and j cross k, I cross k, from this term, and that's all. Let's start. Del of del x, that is from we have that I cross j a y. Okay, now I cross j, what we have is equal to k cap. Okay, now with this term let's do it. Del of plus del of del x az az. This is I cross k. I cross k, k cross I we know j, so I cross k will be minus of j cap. Okay, let's do for the second one. Del of del y, del of del y, that is j cap into a x, that j cap cross I cap is equal to minus k. I cap cross j cap is equal to k, so it is the minus k. Okay, now we till now we have that. Now let's start go through further what I have learned. That now j cross j will be 0, del y plus del of del y az, j cross k, j cross k is equal to I, we have the I cap. Okay, till now we have this. Now plus del of del z, del of del z, x will can have x, k cross I is equal to j cap. Okay, plus del of del z, del of del z ay, ay, the it will have what will have ay, then k cross j is equal to minus I cap, minus I cap. Okay, look, every terms have one k cap and another minus cap. In k cap we have an I cap and another minus I cap. We have an j cap and another minus j cap. We'll put it the together for unit vector. Write down in that form of, suppose we start with the I cap from where we have I cap, we have that I cap in there, del of del y az minus, okay, minus because that from del of del ay del z. Okay, plus write down in the z form. What will be in the z form? Sorry, j cap form. J cap form will be del of del z ax, that term, minus of that term, that is called del of del x az. Okay, plus another term k cap. K cap is written as where we have this, we have del of del x ay minus another del of del y ax. Okay, we have till now we had this, till now we have find to this. Okay, now look at this. This is basically the form of curl, mathematical form of curl. It also we can write in a matrix form. How we'll write it in a matrix form? Okay, let's see. We'll write in a matrix form, write that I j I cap, look in the, and that is k cap. Okay, well, okay, this term what will be there, that can be written of del x del of del y and del of del z. Okay, and this term will be written ax ay az. So this is, we have find the curl of vector a. And that will be look like this in matrix form, or in general the curl is look like that. Now let's imagine what we have learned in our first part in the beginning of the video, that where we are talking about the physical meaning of the curl. The physical meaning of the curl was the application of a vector in that opposite direction, so that an force create where a rotational motion create. Look at that, this is in the opposite direction, two vector applied in an opposite direction, so an rotational motion create. This is the curl, how mathematically significant, and that mathematical significant how really work on physical significant too. Let's have an example for understanding the curl better. To understand more deeply, let's take an example. We have an important vector relation with us. To understand curl more deeply, let's prove by this. As an example, we are proving this relation. Okay, this relation is curl of grad phi is equal to 0. We have to prove this. Okay, now we know as a grad phi. The grad phi is, know the grad phi is del of del x I cap of phi, of course, plus del phi del y j cap plus del phi del z k cap. That is, we know as a grad phi. For the finding the curl of grad phi will be look like del of del x I cap plus del of del y j cap plus del of del z k cap. Okay, cross product of this thing. Okay, cross product of this. Write down in full area that del of del x I cap plus del of del y j cap plus del of del z k cap cross of del phi of del x I cap plus del phi of del y j cap plus del phi of del z k cap. Till now we have to this. Okay, now what we'll have to find now, it's that equal to, we have already know what is, how the curl works and how the cross product works. From this we can write this, the in our theory part we have studied del of del y del phi of del z minus of del of del z del phi of del y, this of I cap, plus we can write phi of del x minus del of del x del phi of del z, it is j cap. In this part we can write, just can we write here? Okay, there is enough space. Del of del x d phi dy minus del of del y d phi del x k cap. Okay, till now it's is it clear? Now look at this, that is del 2 phi del yz. My so it can be written as it can be written as del 2 phi del 2 phi del y del z, that minus that del 2 phi del y del z I cap. Same way we can write that del 2 phi of del z del x minus del 2 phi of del z del x, that is j cap. Okay, we got the j cap plus another last one is k cap. How it can be defined? Del 2 phi by del x del y minus del 2 phi by del x del y k cap. Now look at this, these all terms are same, equal and opposite, so this is 0 I cap plus 0 j cap plus 0 k cap is 0. Okay, this vector is called 0 vector. Okay, thank you for watching till. If any curl is 0, then if the curl of is 0, then this vector is irrotational vector. Okay, and another more important thing, if you find that curl of any vector is 0, then this vector is irrotational. Thank you so much for watching.